Though both your car or truck and your boat's engine has a water pump, they are vastly different and it could get confusing when talking about them. How long it takes to change one, are they rebuildable, what's it cost to buy one, and many other questions that could arise. Interestingly enough though, the reason we are talking about this here on a boating channel is because I just had to change the one on my truck because it was leaking bad enough to where I couldn't make it to the other end of the island without starting to overheat. So what a perfect time to compare these two water pumps. Now I must admit that I really don't enjoy working on cars, they aren't my specialty, and so by no means am I any kind of an expert at how to change the water pump in your car. All the car engine water pumps that I've ever changed, which isn't many, but they have all been this all-inclusive type of an assembly that is located on the front of the engine. And I would start by letting you know that you should remember to drain the radiator before you start, something that I forgot to do. And then we can take the belt off of the engine, usually done by releasing the tension from the tensioner, which is something that every engine that uses a belt will have. This one just takes a 15mm wrench or socket to turn it, which releases the tension and then allows us to slip the belt off the engine. If you are going to save your belt and not change it when you do something like this, I was always told that it's important to put it back on the same way it came off so that it continues to spin the same way it has been. Now I don't know if that is important or true or not, but that's the habit that I've formed. So once the belt is off, we can get to the worst part of this entire process, and that's the experience of having to get this fan off of the water pump before we can pull the actual water pump itself. And this thing is a nightmare of a situation to have to deal with. I'm sure there is a tool to make this easier, but fortunately the new water pump comes with a new pulley or whatever this thing is called, and so we can just take a pair of large vice grips and crimp it onto the pulley. Then we'll spin it around until the vice grips are against this bolt here, allowing us to then use a cheap trick with another wrench to get some solid leverage from the vice grips, where we can put the box end of the wrench on the vice grips to hold them in place. Then we'll just use the biggest adjustable wrench that we have, and with all this leverage and just enough strength, you can get that fan to break free from the water pump spindle. These things get super tight on here, so you will probably also end up using some kind of a lubricant like some Kroll or PB Blaster to help you out, in order to break the seal of the fan and the spindle. Once that's free, we can unscrew the fan and pull that out of our way, leaving us with about 8 or 10 bolts on the water pump that we need to remove. Once we have all those bolts out, you'll see what's left of the antifreeze pour out of the engine block, and we can pull the water pump out and look at the main differences between this pump and what you will find in your boat's engine. The car water pump is interesting because it utilizes a solid impeller. Unlike what we have in an outboard or an inboard, both the outboard and the inboard have a rubber vaned impeller that uses the flex of the rubber to help and build the pressure and flow of water to move it from the lower unit water pickups to the engine block where it cools down the engine. You'll find this impeller on top of the lower unit on an outboard, a stern drive, and then on inboards you will find it inside of a water pump housing that gets water fed to it by a pickup on the bottom of the boat, and it will be driven by the accessory drive belt on the engine. Something else that we could compare it to is going to be the impeller that you will find on your jet boats, jet drives, or jet skis. They also have a metal impeller, not a rubber impeller. Now I don't work on many jet driven boats or jet skis, so I don't know too much about them outside of the fact that they have the solid impeller and that the water intakes are usually screens on the inside of the impeller that then feeds a hose that goes into the boat and around the engine, which does give the solid impeller some similarity to the jet boat impeller, but not much for the outboard's rubber impeller. Another comparison though is going to be the pressure that is produced by the impeller. Technically, I'm guessing they will produce about the same pressures when comparing them at the same RPM, but that's where we get into the major differences in what a car's engine and a boat's engine goes through and how the cooling systems function differently. In the car, normal cruising speed down the highway, the engine is only going to be turning about 2,000 to 3,500 RPM. Depending on how fast you are going, and that is going to be about the highest the RPM is going to go in the car, which will only make the water pump produce around 12 to 16 or so psi in the cooling system. And since the cooling system of the car is a closed cooling system, or what is called closed loop, you have a pressure relief cap on the radiator or the fluid container here. These caps usually relieve the excess pressure around 15 to 21 or so psi depending on what your car's engine is set up to be, which is completely different compared to your boat engine, where most of the cooling systems are not closed loop, especially on outboards. For more information on the cooling system and reasons why an outboard will overheat, we have a video for you covering exactly that. But when you talk about cruising and hitting wide open throttle in your boat, the engine is going to be doing anywhere from 4,500 to over 6,000 RPM, which is a massive difference compared to the car. And for this reason, the speed of the engine spinning is spinning the water pump impeller twice as fast in your boat, which results in much higher water pressures than what you will find in your car. Sometimes at wide open throttle, you can see water pressures in the mid to high 20s, depending on how new the impeller is, the water pump housing, thermostats, and all the other items that we covered in the video on overheating and what makes up the cooling system to your boat's engine. And since this isn't a closed loop cooling system, you don't have to worry about the higher pressure when in a vehicle or other closed loop cooling systems you do, which is why they have that pressure relief cap to make sure and allow the pressure to bleed off in case it builds too high. Now this can get into a lot more technically advanced discussions which I'm not qualified to even begin to talk about. Things like the boiling point or vapor point of the water and the different pressures that can raise and lower that point of the coolant, the BTU ratings and the coolant flow volumes, all the things that the engineers know about to make these engines run more and more efficiently. For me, I'm not that smart though, so all I can show you is just how to figure out where it's leaking and get it fixed. On the case for our truck, all we have to do now is install the new water pump with the gasket, and usually we use a little bit of gasket sealant to go around the O-ring. Then just put the bolts in, tighten them up, and reinstall the fan blade and put everything back together. Then we can fill it up with antifreeze until the level gets right here to the markings on the container for a cold level of the fluid. And that is what we're all about here, helping you keep your stuff running. So you'll want to make sure you are subscribed to the channel and visit us at bornagainboating.com, where we can teach you all about your boat and your boat's engine. Now you can learn all about your boat's engine cooling system in this video here, where we discuss what will cause them to overheat. Now thank you all for hanging out with us this week and smashing that like button. We look forward to seeing you next week.